Welcome back to Microbial Concepts. So in this video, we are going to cover few other points related to clean room, which are sources of contamination, then how to eliminate or minimize those sources of contamination, then HEPA filters, HVAC system, pressure maintenance, etc. Okay, so do watch this video till end to know the interview questions and see if you are able to answer those or not. Okay, so let's start. So just a quick revision here. So what is a clean room? So clean room is actually a specialized environment designed to maintain extremely low levels of airborne particles. That means it is a room which has a very specialized controlled environment where you have very low levels of airborne particles. What kind of airborne particles we are talking? We are talking about dust, microbes, say pollens, or some chemical vapors which can interfere with your product, right? So where these clean rooms are used, so they are used in variety of industries like semiconductors, then pharmaceuticals, biotechnology related industries, medical device manufacturing industries, aerospace, and else. Then clean rooms, they are typically used they typically use a combination of air filtration, pressure differentials, temperature, humidity control, and a specialized cleaning procedures to maintain this controlled environment. Why? So you need to filter air, right? Because that is again a source of contamination. You have to maintain the pressure. Why? Because you need or you will allow the air to flow from high pressure, high clean room to a low pressure, less clean room. Okay, that's the way you control your environment. Then again, as you control the pressure and air, you also have to control the humidity and temperature because you have to work on say manufacturing or say processing, production, or packaging your product. So it also depends on your product that what kind of temperature and what kind of humidity is required. Plus you also have to think that the person who is working in that clean room should be comfortable. Okay, so that kind of temperature and humidity is to be monitored and controlled. Then cleaning procedures. Now it is a clean room, so you have to clean it properly each and every day. Not just cleaning, you also have to sterilize, say, uh, the specialized garments that we use while entering a clean room. Okay, so there are different types of cleaning, disinfection, or sterilization processes that are to be followed to maintain this controlled environment in a clean room. Why you have to do all this? Because the ultimate goal is to minimize your contamination, right? So the goal is to minimize the amount of particulate or microbial contamination in air and surfaces within the clean room. Then to avoid damaging your sensitive equipments, then interfering with your critical processes and contaminating your product that is being manufactured. So that is the purpose of clean room. Okay, so now about the classification system of a clean room. So there is a ISO system of clean room classification, and then there is FS system of clean room classification. Now let's see ISO system. So it is the classification depending on which you classify on the level of cleanliness. So the ISO 1 is the cleanest and ISO 9 is the least clean. Okay, clean room. So you can see ISO 1, 2, 3, 4, 5, 6, 7, 8 and also 9 is there. Now the 9 is actually very least clean. So sometimes it is mentioned in the table and sometimes it is not. So what is the ISO classification system? So it depends on the level of cleanliness, and not just ISO, also FS. But the difference between ISO and FS is FS stands for Federal Standard 209 or 209E. Okay, and the FS 209E is equivalent to these ISO classes. Okay, so you must have heard about class 1, class 10, class 100, class 1000. So how it goes? So ISO 3 is equivalent to FS class 1. ISO 4 is equivalent to FS class 10. ISO 5 is equivalent to FS class 100. ISO 6 to class 1000. ISO 7 to class 10,000. ISO 8 to class 100,000. Okay. So this is how the classification of clean room is done. So it is mainly upon the maximum allowable concentration of the airborne particles which are allowed to enter per cubic meter of the air. Okay, not just number of particles but also the size of particles, that is also very important. So you can see another table here. So the number of particles per cubic meter by micrometer size, you have to compare the number with the size of that particle. So you can see, for example, in ISO 3 you can check the zero point 0.1 micrometer size particles, they are 1000. Okay, so 1000 particles of zero point 0.1 micrometer are allowed. 237 of zero point 0.2 micrometer are allowed. 102 of zero point 0.3, 35 of zero point 0.5 and 8 of 1. Okay, so this is how you compare the number of particles depending on the size of particles. And this is also the table that is mainly used while validating the clean room. Okay, so yes, this is very important part. So you may get questions on classification, what is the difference between ISO and FS standard, and what is the or what are the main points depending on which the class or there is difference between class, say class 10 and class 100. Okay, so you have to compare for ISO 4 and ISO 5. Okay, so you need to tell that there is difference between number of particle size which are allowed per cubic meter by micrometer size of the particles. Okay, that is compared. So what are the sources of contamination in clean room? Now the purpose of clean room is to minimize contamination, right? But still there can be contamination in a clean room. That is a main problem, that still when you are working in a clean room you get contamination, that is a main problem. So you cannot always get rid of contamination. Okay, you cannot say that yes, this particular clean room is having 0% of contamination. Okay, that will never happen. Why? Because there are different sources of contamination and those are what we are going to study. So first is people or the workers who are working in that particular clean room. So people are significant source of contamination. Why? Because our body, it sheds skin flecks. Some suffer from hair fall. Okay, or even our clothes, the one which we use, street clothes. You cannot just enter a clean room by on your street clothes, right? We have to wear designated clean room garments. So the clothing fibers are also a source of contamination. So that's the reason why first very important source of contamination that is considered in a clean room is people. Second, equipment. Now equipment which are used in clean room can generate particles through friction or vibration. Okay, even a metal piece which is constantly under friction can generate very small fine particles. Okay, so that can also contaminate. If you are packaging, say, a particular API, that is active pharmaceutical ingredient, and if this particular metal particles, if they are getting mixed into that drug, then it is very harmful, it is very hazardous, right? So you have to keep this point in mind. Then third is airborne particles. Now we have HEPA filters, right? Then why to worry? No, that's not how it works. The airborne particles, they can enter from, say, anywhere. Okay, particles can enter a clean room through the air supply or from adjacent areas. Okay, so even though there are HEPA filters, it can happen that over the period of time, if HEPA filters are not cleaned properly, or there is a breakage in HEPA filter, then it can happen that particles can easily enter your clean room. Correct? So there is a proper schedule which is followed for even checking your HEPA filters and validating them. Okay, then fourth is processes. Now different types of processes are followed in a clean room, right? So say for manufacturing purpose, or say for packaging purpose, for etc etc. During that processes also, some particles or some gases can be generated, and that can contaminate your clean room. Then fifth, materials. Now materials or supplies which are taken in inside the clean room, for example some raw materials, some packaging materials, or some other supplies, they can also contaminate your entire clean room. Okay, so you have to um, always be alert while taking anything inside clean room. If it has to be disinfected, if you are able to disinfect something, then you have to disinfect. Now for example, say a raw material which is used for manufacturing a API is to be taken inside clean room. You cannot disinfect a powder form, okay, all the time by using any chemicals, because that will interfere with your product. Okay, so there are some different points, different protocols which you have to follow when you are working in clean room to minimize the sources of contamination. Okay, in next slide you will learn how to eliminate these sources. Clean room, then how to minimize or eliminate these contaminations in clean room. So first, you should have a proper design and construction of clean room, depending on what kind of work is to be carried out, what kind of product is to be manufactured or packaged, etc etc. Depending on the purpose, the designing of the clean room and the construction is to be done properly. When you do this, you will automatically minimize the particle entry and you will get a controlled environment. Then use HEPA filters, ULPA filters, air locks, pressure differentials to control the airflow and prevent contamination from entering or leaving the clean room. Then regular cleaning and maintenance of equipment and surfaces to minimize the particle buildup. Even I think you must have noticed that there is epoxy flooring. Okay, there are no corners in clean room. Why? To avoid accumulation of dust. Okay, then use of specialized clean room garments, gloves, shoe covers, etc etc to minimize particle shred from workers. Then implementation of proper protocols for entering and working with the clean room, including training for the persons who are working, then gowning procedures to be followed, and restricted access. Not anyone can enter a clean room. Okay, there should be restricted access. Then regular monitoring and testing of clean room environment to ensure it meets the required cleanliness standard. Okay, not just air is to be monitored, the temperature, the pressure, the humidity, everything has to be suitable for working for efficient working of a clean room. Then what is HVAC? A very important um, part of clean room, I will say. So HVAC, it stands for heating, ventilation and air conditioning. It refers to a system. Okay, it is not just one thing, it is a system that provides indoor controlled comfort by regulating temperature, humidity and air quality. What all it covers? It regulates temperature, humidity and air quality of a building or a room. The system includes various components through which it works together. So the first is, it has a heating equipment to provide warmth during cold weathers. It also has cooling equipment which provides cool air during hot weather. It has ventilation system that brings in fresh air from the outside and removes stale air from the building, which maintains the which helps to maintain the indoor air quality and prevent buildup of indoor pollutants. Okay, for example, a exhaust fan which you have at your home. Okay, what it does, it removes the stale air from your home, right? So that's the way even the ventilation system of HVAC also works. Then there should be proper duct work. Okay, now there are ducts through which air comes in and stale air is taken out. Okay, so duct work and air distribution system is again another part. Then controls and sensors that regulate the temperature, humidity and air quality within the building and allow for adjustments to be made for HVAC. Now there are sensors for temperature and humidity. You can see a clean room monitor, a, a device which looks like this, which keeps continuous recording the temperature and humidity, and it helps the person who is working there to check whether the temperature is appropriate or not, the humidity is appropriate or not. Okay, and depending on that the adjustment in HVAC can be done. Now HVAC systems are essential for maintaining the comfortable and healthy indoor environment. For example, for a microbiologist, if in clean room you are working with say isolation, or you just want to check the microbial load in your non-sterile product that your company is manufacturing. So if you have to incubate at room temperature, then you have to check whether the clean room has the room temperature or not, whether it is at 27 degree or not. You have to check that, otherwise you will not get the desired result for microbial growth, correct? Then proper maintenance and operation of system is crucial to ensure its functioning properly, efficiently and effectively. So another part of clean room is pressure maintenance. Okay, maintaining pressure of a particular clean room is very important because you have to get that controlled environment. Okay, so even after temperature and humidity, pressure is also important. Okay, so it is a part of HVAC system, and there are pressure gauges which are used to maintain these pressure differentials. Okay, the term that is generally used is actually pressure differentials because there is difference in pressure between two rooms. Okay, so to maintain the difference, to maintain those values of pressure between two rooms, you use pressure gauge through which you can take reading, and if you want to adjust pressure of a particular room you can do that. Okay, so the innermost room for which is used for testing or say for production purpose or for say packaging, that will have the most clean air and high pressure. Okay, so for example here, let's take that you have two rooms. Okay, the innermost room where actually you are performing the testing of product, say it is a clean room in quality control. So you have that MLT, that is microbial limit test room, where you perform all those testings. So that room will have the most clean air and high pressure as compared to the one which is adjacent to it or one which is outside, okay, next to that MLT room. So how it works? So the air will flow from the cleanest area towards the less clean area. That's the reason you need the air to flow from the cleanest area to less clean area. That's the reason why you need to maintain the pressure difference. Okay, so you will see that some of the seniors, they, while talking about pressure maintenance, they say that this room has positive pressure as compared to the this room. Okay, so what does the positive and negative denotes here? Positive means it, when you compare between two rooms, one room will always have a high pressure and that is denoted as positive, and one which has less pressure will be denoted as negative. Okay, so after temperature, humidity, you also need to focus on pressure. So I hope this concept is clear. So last part of today's video, that is HEPA filters. So HEPA stands for high efficiency particulate air. I hope you have studied HEPA filters in your theory as well. So here also in clean room areas where HVAC systems are placed, HEPA filters come into picture. Okay, so it is a type of air filter that is designed to remove very small particles from air. So to be classified as a HEPA filter, the filter must be able to remove 99.97% of particles that are of zero point 0.3 microns in size or larger. The HEPA filters are commonly used in HVAC systems in clean rooms, and they are highly effective at removing what? Allergens, dust, pollen, bacteria, viruses from air, and thus they can provide a very good quality of indoor air, okay, and prevent the spread of airborne diseases. Now HEPA filters, they work by forcing air through a dense network of fine fibers that can trap particles as the air passes through. The filter is composed of multi-layers of a pleated material. That means there are many layers of this filter, and which increases the surface area of the filter, and thus the air will get more filtered through the this kind of HEPA filter, okay, and thus it will improve the effectiveness of the HEPA filter. The fibers used in HEPA filters, they are typically made of materials such as glass, synthetic polymers, or ceramic fibers. So they are highly effective in trapping particles. Now HEPA filters, they require regular maintenance to ensure they continue to function effectively. And yes, it is also a filter. So over the time, cleaning of this type of filter, and you can say changing, may also require. So after watching this video, I hope now you are able to answer a few of these interview questions. So first and very basic is, what is clean room? What are its main characteristics? Then why a clean room is important in industries like pharmaceuticals, biotechnology, electronics, etc. Then what are the different classes of clean rooms and how are they classified based on the particle count? Then what is HEPA filter, or you can say you can get a question like what is HVAC system and how does it work? Then what are different types of clean room garments? Why are they necessary? Then what is donning? What is doffing? Okay, another cross question depending on how you answer this. Then what are the sources of contamination in clean room? Okay, how can you get them eliminated? Then how are clean rooms validated and qualified, and what are the acceptance criteria? So this question is actually for very experienced candidates, okay, who have already worked on validation on clean rooms, okay. For those only this can be a interview question asked. Then what are different types of environmental monitoring studies that can be performed in a clean room? So for example, for microbiologist, you do plate exposure, that is bioburden testing, right? Then yes, there are temperature, humidity testing, etc. Then what is the difference between clean rooms of different classes such as class 100, class 1000, class 10,000? So what is the difference? The difference is on the number of particles which are present per cubic meter of air and the particle size as well, okay. So I hope this video is helpful to you. Do give a thumbs up, do like my video, do share my videos with your friends, and do subscribe to my channel. Thank you.